Okay, picture this. You wake up, stretch, look out your window, and everything seems totally normal. Just a regular morning, right? But then you notice something completely terrifying. The trees aren't just rustling in the wind. The clouds aren't just drifting. The ground itself is moving. Buildings, oceans, cars, literally the whole atmosphere is suddenly tearing across the planet at supersonic speed. Welcome to this explainer. Today we're diving into one of the wildest and frankly most terrifying scientific thought experiments ever conceived.
So, what actually happens if the Earth just suddenly stops spinning? We just went from a peaceful morning to the literal end of the world in a matter of seconds. And the reality of this scenario is way more catastrophic than most people even begin to imagine. Today, we're going to break down exactly what the science of this apocalypse would look like. Okay, let's dive into this. Right now, as you're watching this, you probably feel like you're sitting perfectly still. But you aren't. Depending on where you live on the globe, the ground beneath you is ripping through space at upwards of 1,600 kilometers per hour. To put that massive planetary force into perspective, imagine looking outside and seeing the world rocketing by faster than the speed of sound. If we suddenly hit the brakes, cities would vanish, mega-tsunamis would swallow continents, hurricane-force winds would flatten absolutely everything in their path. But before we get to the total destruction part, we really need to understand why this massive force exists in the first place. The physics of spin and why the Earth rotates. Think way, way back to when our solar system was just this chaotic, swirling cloud of gas and dust. Gravity pulled everything together and it just started to spin. The crucial concept here is the conservation of angular momentum. Basically, because space is a vacuum, there was no friction to slow things down. So that initial spin from Earth formation 4.5 billion years ago, it never disappeared. It's that ancient preserved momentum that gives us our exact day length right now, 23 hours, 56 minutes, and 4 seconds. And because of that consistent spin, we arrive at this staggering number. If you happen to be standing at the equator right now, you are traveling at approximately 1,670 kilometers per hour. That is significantly faster than a commercial airplane. Honestly, the only reason you don't feel like you're strapped to the wing of a jetliner is because everything around you is moving at that exact same speed. The air you breathe, the oceans, the buildings, your own body, it's all perfectly synchronized. Section 2. The instant global catastrophe. What happens when the spin stops? Now, what's really interesting about this slide is how it illustrates inertia. Basically, inertia is an object's tendency to resist a change in its motion. So imagine the Earth is a giant vehicle driving at 1,670 kilometers per hour, and it suddenly slams on the brakes. Well, everything that isn't firmly bolted to the Earth's core is just going to keep moving at its original speed. People, cars, airplanes, animals, the oceans, the atmosphere itself, they all instantly transform into 1,670 kilometer per hour eastward projectiles. This cascading destruction would happen almost in the blink of an eye. Step 1. Buildings and skyscrapers twist apart and collapse under the immense stress, and bridges completely fail. Step 2. The atmosphere keeps moving, whipping up winds over 1,600 kilometers per hour. That is vastly stronger than the worst tornadoes ever recorded in human history. Literally nothing designed by us could withstand it. And step 3. The oceans don't stop either. Billions of tons of water would keep their momentum, racing across the globe as mega-tsunamis hundreds of meters high, just completely redrawing the map of the world. Section 3. Water, heat, and radiation. The long-term effects. So let's suspend our disbelief for a second and say by some miracle, the planet doesn't just shatter. Well, we'd wake up to a terrifying new reality. Because Earth is still orbiting the sun, just not spinning, a single day would now last an entire year. The sunny side of the planet would be scorched by 6 continuous months of daylight, with temperatures easily climbing over 100 degrees Celsius. Meanwhile, the dark side is plunged into a 6-month freezing night, dropping below minus 100 degrees Celsius. In these absolute extremes, plants couldn't survive. Agriculture would completely collapse, and our global ecosystems would quickly die out. And this brilliantly illustrates an often overlooked consequence. The rotation doesn't just affect the surface. It drives the molten outer core deep inside the Earth. That moving core generates our planet's magnetic field. If the spin stops, those internal dynamics are completely disrupted, and over time, our magnetic field weakens. Without that invisible shield, harmful solar and cosmic radiation would just bombard the atmosphere. Satellites would become highly vulnerable, power grids would fail, and any surface life left would face deadly levels of radiation exposure. Section 4. Can humanity survive this? The ultimate challenge. We've looked at the wind, the water, the extreme heat, the ice, and the radiation. It paints a remarkably bleak picture for the future of our species, right? So we have to ask, could anyone actually live through this? If the Earth stopped instantly, the immediate answer is probably very, very few. The only humans who might stand a microscopic chance against those initial shockwaves and tsunamis would be folks already located deep, deep underground in bunkers or extensive cave systems.
But surviving the initial disaster is an entirely different ballgame than surviving the aftermath. Even for those lucky few huddled in bunkers, they'd eventually have to face a surface world where modern civilization has been totally erased. With ecosystems dead, food production would completely collapse, fresh water would become incredibly scarce. Humanity would literally be facing the absolute greatest survival challenge in its entire history, and it's highly likely our modern civilization would disappear forever.
Section 5, the reassuring reality, a gradual slowing. Okay, everybody, let's let out a massive collective sigh of relief because this instantaneous stop, it's entirely a scientific thought experiment. Physicists use it to understand things like inertia and planetary dynamics, but it is physically unrealistic and will never happen naturally. The actual reality is that the Earth is slowing down, but in an incredibly, beautifully safe way. Our planet is losing about 1.7 milliseconds off its day per century. This microscopic slowdown is caused by tidal friction from the moon's gravity pulling on our oceans. At a rate of 1.7 milliseconds a century, it would take millions and millions of years to notice any meaningful difference, giving life plenty of time to adapt. There is absolutely no realistic risk of the Earth suddenly grinding to a halt.
Which leaves us with this final, really calming thought. Earth's spin is something we almost never think about. It's just a given, you know? Yet every single sunrise, every gorgeous sunset, every complex weather system that brings us rain, quite literally, every moment of our lives depends entirely on this unseen, constant spin. Without it, our thriving world becomes a hostile wasteland. Truly, sometimes the most ordinary things are the ones keeping us alive. Thank you so much for joining me on this wild thought experiment through the extremes of planetary physics. By breaking down these incredible concepts, we really gain a much deeper appreciation for the delicate balance that allows us to exist at all. But because the universe is full of endless questions and fascinating mysteries, what will we explore next? Keep wondering, keep learning, and I'll see you in the next explainer.